All right, so this was one of the questions that we talked about last week, and this is showing that the points, this one says specifically form the vertices of an isosceles triangle. On your quiz, it's going to tell you to find the lengths of all three sides and then classify it, so it won't tell you a specific one. If you're classifying it as isosceles, you're showing two sides are the same. If it's equilateral, you're showing all three sides are the same. If it's a right triangle, that you're showing that a squared plus b squared equals c squared. So if I wanted to find, and these are not labeled, they will be on your quiz. Let's say I wanted to find the lengths of all three sides. If I wanted to find a, b, I would do the square root of 3 minus 1 squared plus 2 minus a negative 3, which becomes plus 3. And I get 2 squared plus 5 squared, 4 plus 25, which is square root 29. If that can be reduced, you need to make sure it is reduced when you give me that answer as far as the length goes. When you're using it to show something, it doesn't have to be reduced. But when you're giving it, like the quiz is actually going to say, okay, what is AB? And then you're going to write it on the line. That, whatever's there, you want to make sure is a simplified square root. Obviously, 29 is prime, so it doesn't matter. But if it was able to be reduced, you would need to. Then I can do BC. So negative 2 minus 3 squared plus 4 minus 2 squared, and I get the square root of negative 5 and 2, and I get 25 plus 4, and there's my 29. So I got lucky by picking those two first to show that this is already isosceles. You could have graphed them to try to give you an idea, but also on your quiz, it's going to ask for all three side lengths anyways, so you're going to end up doing all of it anyways. So like negative 2 minus 1, and then 4 minus a negative 3, negative 3 squared, 7 squared, 9, 49. And then 58's even, but it would go in 2 and 29. None of that repeats. So if I was to give all three side lengths, I would just include all three. Yeah, but it's not gonna. It's gonna say find all three sides and then verify and then show which kind it is. And it could be isosceles, equilateral, right, or neither. Is it possible for you to have a right and an equilateral? Can the triangle be both right and equilateral? No, why? The hypotenuse has to be longer than there too. Is it possible for you to have isosceles and right? Yeah, 45, 45, 90 triangle is isosceles and right. So it could be that there are two of these, right? So if it's isosceles, I would also test to see if it's right. And in that case, I would do the square root of 29 squared plus the square root of 29 squared equals the square root of 58 squared. And this is 29 plus 29. And in this case, this is not only right, it is also isosceles. So on the directions here, it said just show that it's isosceles, which meant as soon as I found the two that are the same, I'm done. But on the quiz, it's not going to say that. On the quiz, it's going to say find all three side lengths and then classify it. So this would be both isosceles and right. Okay, and I know isosceles is not the easiest word in the world to spell if you get close and I can understand it. It's okay. I'm a math teacher. I'm not going to get you on the grammar, okay? But that is a possibility, okay? Does that make sense? That it could be both? Yes? Okay. And we won't forget to check for that. All right. Second question said, find the center and the radius of the circle with the endpoints negative 1, 2, and 3, 4. Then find the equation of the circle. So our end goal is the equation, which is x minus h squared plus y minus k squared equals r squared. And what we are given are the endpoints of the diameter. So none of that is what I need at first, right? I need the center first. How do I find it? Midpoint. Good. So I'm going to use these two, and I'm going to find the midpoint, which is x1 plus x2 over 2, y1 plus y2 over 2. So negative 1 plus 3 divided by 2, and 2 plus 4. And I get 2 over 2 and 6 over 2, which is 1, 3. So that's the HK. God bless you. That's the HK part. Now, if these were fractions, I would avoid them as much as I possibly could. Obviously, I'd have to put them in the equation at the end, but I wouldn't use the center and a point at that one to find the radius. I would use the 2 endpoints, and then I would find the distance formula, and then I would cut it in half, okay? But because that's a whole number, in my opinion, it's easier to use the midpoint, or the center, which is my HK, and then one of these points, okay? I would also say one has a negative, one doesn't. People, as smart as you all are, you make some interesting moves when it comes to subtracting a negative, okay? That's where people make some silly mistakes. So I would take the center and I would take the positive coordinate point and make that my xy. So 3 minus 1 squared plus y minus k squared equals r squared. 4 plus 1. And my r squared is 5. If it wanted the r, it's the square root of 5. But it just says r squared, so I'm just going to take the h, the k, the x, and the y. The h, the k, and the r and plug it in. So x minus the 1 that comes from here squared plus y minus the k that comes from here squared equals r squared, which is 5. And that's the end goal. That's what you're looking for at the end. Now on the quiz, it's going to ask you, you're going to get one that's similar to that. You're going to get one that gives you the center and that give you the equation. You're going to have to find the center and the radius, and then you're also going to have to graph it. So if I was to graph the square root of 5, I would approximate that to be what? A little bit bigger than 2, right? Because square root 4 would be 2. So when you're graphing and it's not a perfect square, you're just going to approximate it. But if I was to graph that circle, I would be going to the right 1, up 3, and I'd count 1, 2, a little bit past it, 1, 2, a little bit past it, 1, 2, a little bit past it, and I'd make the circle as best you can. So the 3 equations you needed to know from C1 were the midpoint, the distance, and then the standard form of your circle. All of that will be on the quiz. Questions? All right, let's move into C2. So the homework solutions are published. They opened like at 8:05 this morning. So you can check your answers. If you've got questions, please speak up. And then tomorrow we'll have a little bit of breathing room. We're gonna do like the C2 warm-up, and then we'll review for your quiz a little bit. So we'll get to go over all that stuff. This week is weird because tomorrow is the freshman meeting in first class period. Wednesday is the seniors. Thursday is the juniors. Friday is mass. Monday is the sophomores. Okay, so every morning this week we're gonna get some sort of interruption. All right, C2 is graphs of equations. So we start real basic. Like if a point is on a graph, then when you plug it into the equation, the result is a balanced equation. So you could see something like, is 1, 2 on the graph of this equation? And all you have to do is plug it in. If left side equals right side, it's a yes, okay? It's also your default when you have no idea how to graph something. You can plot a point, okay? You can plot a point of any kind of graph. So this one just says to determine whether the given points are on the graph of the equation. So here's my equation, and this is a 2-part question, so you're not plugging both in at the same time. I'm asking if 0, negative 2 is a coordinate point, and then also 1, negative 2. So here's my x and here's my y. 0 squared plus 0 times negative 2 plus negative 2 squared equals 4. Everywhere there's an x, I plugged in a 0. Everywhere there's a y, I plugged in negative 2. And I get 0 plus 4 equals 4. Sorry? No. It'll give you the equation. Yeah. So because 4 equals 4, this one is yes. 0, negative 2 is on the graph of that equation. And then 1, negative 2, 1 squared plus 1 times negative 2 plus negative 2 squared equals 4. 1 minus 2 plus 4. 3 does not equal 4, so that's a no. All right, so now you're gonna get these graphs. You're gonna get an equation, and some of them might be familiar and some of them might be really weird. And so the goal when you're actually sketching the graph, the first one would be, if it's possible, rewrite the equation so that one of the variables is isolated on one of the sides of the equation. And I would say normally we want it to be a y equals, but it won't always be a y equals. If the y is squared and the x is raised to the first power, now it's an x equals. So that's why it says, if possible, rewrite it so that it's isolated. Then if you have no idea what that graph looks like, obviously if it's a line, hopefully we remember how to graph the line. But if it's a parabola and you're like, I'm not really sure what this looks like, it's not in standard form, so you can't just shift it around, then you can make a table of values and you can just do a t-chart, okay? Then you can plot those points and then you can connect them as close as you can. They don't have to be perfect, okay? But it shouldn't be choppy. It's not like we're not doing piecewise functions yet. All right, so A literally says use the t-chart. Obviously, that is a line. I should be able to graph it without it, but if it gives you the t-chart, you're going to use it. So I'm going to take and plug in -1. I'm going to take and plug in 0. I'm going to take and plug in 1. And I'm going to take and plug in 2. The box underneath it literally just means rewrite it as its coordinate point. So x comma y, x comma y, x comma y. And then I'm going to take and put my points. And draw the line. We'll go back over like slope, intercept, point slope, all that stuff. So right now you literally can rely on the plotting of the points. And obviously you're not getting a line on your quiz. We're baby stepping our way in. What type of graph is B? Parabola, good. Do you know which way it faces? Good. So if it was a negative, God bless you, if it was a negative x squared, it's down. What if it's a y squared? To the right. If it's a negative y squared, to the left. Good. Okay, so you're going to see that stuff because these are not functions necessarily. So you could see things that also face right and left. You could see a circle. You could see a cubic function. You could see all different kinds of things in this section. All right, so if I plug in the -1, the 0, the 1, and the 2. All right, so as it is, I actually only have this kind of graph. I don't even have the other side of my parabola. Knowing that you know it's a parabola, you could always plug in some additional points to have it come back up on the other side. In a little bit, we're going to talk about intercepts and that kind of stuff. That would also help. If it's just that, if it's just a t-chart and you don't even have any other assumption, you could literally leave it with the coordinate points as plotted, okay? Again, in a little bit, we're going to review intercepts. That will help you continue to draw this out. And that's what your quiz is going to ask you to do. It's going to ask you to find the intercepts, the symmetry, graph it. But for right now, with just that t-chart, you could just leave it the way that it is. An incomplete graph. questions on either of those? All right, now let's jump to our graphing calculator. So if you don't have your handheld with you today, you can use the graph on the app on your iPad, okay? You will need it Wednesday. If you haven't purchased one yet and you're borrowing, that's fine. Just make sure it's not somebody that's in this class, obviously. There will be no switching within the class. And realize by the time AP test comes around, you have to have access to your own device because everybody that's taking AP will be taking it at the same time. AP Calc and AP Pre-Calc are the same day, so you can't even borrow from somebody like that. So the best thing to do is make the investment. I know it sucks, but you're going to use it a lot. I'm using my graphing calculator. I'm going to go to the y equals, and I have to type that in. So the 1/30th, you actually, depending on your calculator, can do this a couple different ways. One is if you have a little alpha green button and the one next to it that says link, sometimes that actually gives you a shortcut of a fraction. So if you hit the alpha and then you hit that one and you get a fraction, fantastic. Good for you. I'm not that lucky, okay? The other way to do it is go to math and you go to fraction. Nope, sorry. You're going to math and you're going to fraction on the top and then you're hitting n/d and it will give you the little fraction. The other way to do it is just put yourself some parentheses in front of the 1 divided by 30, close the parentheses. You just want to make sure that you're grouping it correctly. Then there's an X here. The X is the button next to the alpha. Then there's a parentheses. There's an X to the 4th. X to the 4th is X caret 4 minus 10 X squared, which is either the caret or you can actually use the X squared button, plus 39. That little thing in the top is telling me it's working. How are we doing? Graphed? Yes? You don't want the calculator to be what holds you up, or your comfortability level with the calculator, okay? All right, so we're gonna do a bunch of stuff with this. Your quiz is gonna ask you to find the zeros, or when y is, when y is 0. It could ask you for the y-intercept. It could ask you for a specific value at a certain point. So do you remember how to find the zeros from last year? Yeah. You can plug in 0 or? Oh, what if you want to do it from the calculator? Second, trace, and you get the button that says 0, which is 2, and you go there. Now this one is crossing at 0, 0, so its y-intercept is also its x-intercept, or it's 0. If it wasn't exactly at 0, I would want to go left of where it crosses the x-axis. That's what it's asking for. It's saying, where's the left bound? I hit enter. I want to go right of it. I hit enter. And then am I ready for it to guess? I hit enter again. It's going to take you directly to that 0. So this time, x is 0 and y is 0. Because your book doesn't say words like zeros yet, like the C.2 doesn't say words like zeros yet, I wrote on your quiz, find the value of x when y is 0. Like that's how I wrote it, and that's what that means, okay? Eventually we're going to get into zeros, solutions, roots, x-intercepts, but for right now, that's how the wording is on your quiz. Now let's say I want to find a specific value. What happens if I said, tell me what y is when x is 5.2? Do you know how to do that? Yeah. What happens if you go to table? It's going to show me the list of all the, and they're all whole numbers, right? Can I figure out a way to type in a number? Do you remember how? Second, trace, go back to that calc menu and go to value, the very first one. And it's going to say, what do you want the x to be? And I'm going to make the x 5.5 because that's just what I said it is. And it's going to give me the point where x is 5.5, and notice the y there, 119 point, and we're going to round that to the nearest tenth. So 119.5. I'm going to do that again. So I went to second, trace, and the very top one is value. If I wanted to know where 5 was 6.5, I would type in 6.5, where x is, 6.5. And it's going to give me, on the bottom, the y coordinate. We're going to get to All right, intercepts. So this we're going to do without the graphing utility. You obviously can find these using the graphing utility, like by doing the zeros and then tracing the y. So to find the x-intercepts, I plug 0 in for y and then solve. And this is the point where the graph crosses the x-axis. To find the y-intercepts, I plug 0 in for x and find the corresponding y. And this is the point where it crosses the y-axis. These are written in coordinate point form. So it's going to be 0, or a number, comma 0. And then this would be 0, comma a number. So when you write intercepts, they should be in coordinate point form. All right, and then comes symmetry. So if a graph is symmetric with respect to the x-axis, then to test for it algebraically, I replace y with negative y. So you replace the other variable. If I'm testing to see if it's symmetric with respect to the y-axis, then I replace x with negative x. And the test for origin is both x with negative x and y with negative y. And then if at the end of those things, the equation goes back to the original, or each term is the exact opposite, meaning every single term has changed signs on both sides of the equal sign, then my test is successful and it would be a yes, it is symmetric with respect to whichever one I'm testing. So if it says test for symmetry algebraically, that's what that means, and that's what you're going to do on your quiz, okay? Obviously, if you had a graph, if you could fold it top to bottom like a hamburger, that's respect to the y-axis. If you could fold it left to right along the x or the y-axis, then that means it's symmetric with respect to the y-axis. And then the origin is like diagonal. You can either fold it down and over or in reverse. But it's like a cubic function would be symmetric in respect to the origin. If I fold the top down and then from right to left, those overlap. That's the idea. And your x values and your y values have just changed sign. That's what happens there. All right, this kind of puts it all together. So it says graph the following equation using intercepts, symmetry, and additional points. So the first thing I'm going to do is find my intercepts. I'm going to find my x-intercept. I'm going to find my y-intercept. I'm going to test for symmetry. And then at the end, I'm going to graph it. How do I find the x-intercept? 0 for y. So 0 equals the absolute value of 2 minus x. With absolute value, in order to get rid of it, I usually set it equal to the positive and negative version of the number that's there. 0 is not positive or negative, so I just drop the absolute value signs and then solve, and I get x equals 2. So 2, 0 is my x-intercept. Then I go to the y-intercept. This time, I make the x 0. Y would equal the absolute value of 2, and the absolute value of 2 is 2. So my y-intercept is 0, 2. Now we test for symmetry. So for x-axis, I'm going to plug in a negative y. For y-axis, I'm going to plug in a negative x. And for origin, I'm going to do both. Then you want to go back and simplify if you can. So is there anything I can do to the negative y equals absolute value of 2 minus x? Nothing changes there, right? So did it go back to the original? Does it look like the original? Does this match this? No. Do they all have the opposite signs? No, only one of them changed, which means this is not symmetric to the x-axis. So it would have to all go back to the original, or they would all have to be opposite. Go to the second one. Is there something to simplify there? What happens to 2 minus a negative x? It becomes 2 plus x. Does that equal the original? No. Is everything the opposite? So again, this is a no. It's not symmetric to the y-axis either. All right, and then the last one. Now there's a negative y. I'm going to simplify what's inside to be 2 plus x. Does it look like the original? Some of it changed this time, right? The y is opposite and the x is opposite, but the 2 is not, which means this is also a no. So this has no symmetry, which is fine. It could have just axis. It could have just y-axis. It could have just origin. It could have x in origin. It could have y in origin. If it has both x and y, it already has origin. But there are times in which it can be none. It could be just one, okay? So if you think about, like, if it just said y equals absolute value of x, what would have happened if I plugged in the negative x? What does an absolute value do? Makes it go back positive. So that would have been one that was symmetric to the y-axis. Does that make sense? Okay. All right, now we're going to graph. So I'm going to use what I know already based on what I found, because your quiz is going to do the same thing. It's going to ask you to find all those things anyways. So I'm going to find the intercepts. I'm going to plot those, which are 2, 0 and 0, 2. What do I know an absolute value graph looks like? Do you remember? It's been so long. What's an absolute value graph look like? It's a V, right? Absolute value, V, right? It's a V. So I know my graph should either do something like this, or it could do something like this. How would I figure out the rest of that? You gotta add in some points. So if you want to plot like -2, -1, anything, you could literally plug in whatever you want there. That's my extra point. Y would equal absolute value of 2 minus a -2. Absolute value of 2 plus 2, which is the absolute value of 4. So when x is -2, y is 4. Now I know the left side is rising. So that's not going to form my V. So I'm going to go to the right. Well, actually, I don't know what the end is happening yet. So far, I know this. I'm going to plug in something like 4. Absolute value of 2 minus 4 is absolute value of -2, which is 2. 4, 2. And that's where my graph starts to come back up again. They do not have to be perfect yet. When we get to like further in the chapter, we do our transformations and we do our parent functions, that kind of stuff. For right now, you're giving me an approximation. It should at least have your intercepts plotted. And then if that's not enough information, you can plot some extra points. God bless you. Questions on that one? So for the first one, your x-intercept when it's set equal to 0, you can either factor this or you can use the even root, which would be x squared equals 4 and x equals plus and minus 2. If you factored it, it's 2 plus x, 2 minus x. So yes, I assume you know how to factor. If that's where you're slacking a bit, there is a video on the module all about factoring. Feel free to watch it in your free time, okay? This one, oh, this should have been 0 here. This one is 0. And this is 4. If I plug in a negative y, it doesn't go away, so it fails the x-axis test. If I plug in a negative x and it goes inside the parentheses with the x, the first thing that goes away is that negative because you're squaring it. So this time it's symmetric to the y-axis. And then negative would have given you for both, and it would also fail the origin. So plus and minus 2 and 4, and we should know it's a parabola. It looks like that.